Hello, ladies and gentlemen, and welcome back. We're looking at question number 5 on the 2008 Euclid paper. Question 5a. In the diagram, the large circle has radius 9 and center 15, 0. The small circles have radius 4 and centers A and B, and they both lie on the line y equals 12. Fantastic. Each of the two small circles is tangent to the larger circle. Fine. It takes a bug 5 seconds to walk at a constant speed from A to B along the line y equals 12. So, there we go. There's our bug walks from there to there. How far does the bug walk in 1 second? So we basically just need to find this distance, whatever it is, d, and divide that by 5, and that'll give us our answer. It's a light bulb question, so we do just need a final answer. Okay, so let's draw our picture here. So we have 15, 0, and a radius of 9 here. That's alright. And then we've got two smaller circles. Both we are told of radius 4. And they lie on the line y equals 12. Okay. So whenever I see circles tangent to each other, I always connect their radii together. And the nice thing about that is if you draw the radii to the point of tangency, they will always form a straight line. This isn't that hard to prove. Imagine the point of tangency. One of the nice properties is the radius connecting to the point of tangency will give you a right angle. But it'll be right angles on both sides, and so we have 180 degrees on the one side. This is a straight line. So we've got 9, 9, 4 here, 4 here. And so in total, we can see that so this one here is A, this one here is B, this one here is C. So it looks like AC and AB are then both 13. Okay. So that's nice. We've got that length there. Now we want to figure out what A to B is. Okay, how can we figure out what A to B is? Well, if we knew this angle here, for example, we could use, say, the cosine law. But I don't know what that angle is. What other piece of information are we given in the question? That we've got y equals 12 is this line. And so AB is, I wrote AB up here, it's BC. BC is 13. AB is parallel to the x-axis. And the distance between this line and the x-axis is 12. That's the height there. So what if from C we dropped a right angle, a perpendicular line here? We know that this would be 12. Let's call this point, say, D. Well, we can see that ADC and BDC are right angled, and they're both going to be congruent to a 13 and a 12, and this is a nice Pythagorean triangle. Okay, it's a right angle triangle with integer side lengths, and if you're not familiar with them, I do recommend you get to know them. The 3, 4, 5 triangle is pretty good. Same with this one here. It's the 5, 12, 13 triangle, but of course we could say something like 13 squared is 12 squared plus AD squared, and we could rearrange and figure that out. But AD and DB, because it's the same triangle in both sides, just one of them's a reflection of the other, they're both going to be 5. And so that tells me AB is going to be a total of 10. So the bug goes at speed x, and so he goes x meters per second, and 5 seconds we get 10 meters, let's say. Well, then x meters per second, the speed of the bug is 10 meters over 5 seconds. This is 2 meters per second. So in 1 second, the bug goes 2. A distance of 2, so 2 meters, let's say. Okay. So in 1 second. And there we go. That's all we needed. So we just need an answer of 2. They don't have units in this question, and that's fine. But you'd say, how far does the bug walk in 1 second? In 1 second, the bug can travel 2 unit distances. I wrote meters just because I wanted a meters per second. I wanted some sort of velocity in units that we'd understand. But the bug goes a distance 2 is a perfectly fine answer here. Okay? So we've also got B part here written. Determine all values of k with k not equal to 0 for which this parabola here has its vertex on the x-axis. So what I might try and do here is put this in vertex form. Okay, so let's get a brand new piece of paper. So we've got 0 is, I saw it was kx squared. Then I think it was k plus 3. 5k plus 3. And then plus 6k plus 5. Okay. So we need the vertex must be on the x-axis. So what sort of vertex form would that look like? So in general, vertex form looks like ax minus h squared plus k. Different k values, by the way. But k here is the y-coordinate, the height of our vertex. And if it's going to lie on the x-axis, then it's going to have k as 0. It's going to have 0 for our height. So this has vertex. I think I wrote a 0 here. It should technically be, it should be y. There we go. So it has vertex h0. So what I want to try and do is transform this into vertex form and say, aha, there we go. We've got a 0 right here. So what this needs to look like is a times x minus h squared. That's what we need to do to match it up. Right, just double checking that I copied it right. Oops, 6k. So we need this to look like a x minus h squared. And this actually isn't going to be that bad. I'm going to expand this out. And so we say something like, by comparing coefficients. So one of the nice things about polynomials, and we're exploiting this fact, is if I have two polynomials and I know that they're supposed to be equal everywhere, then their coefficients have to be the same. The ones in front of the x squared have to be the same, the ones in front of x have to be equal, and so on. Okay, that's a nice property of polynomials. They are unique when you write them out in this form. So by comparing coefficients, we see, so what will we have? We'll have k is equal to a. 5k plus 3, and you got to be careful here, is minus 2ah. And then 6k plus 5 is ah squared. And I'm actually going to need to copy that over to the next page. But this makes it pretty nice. K is equal to a. So we can say 5k plus 3 is minus 2kh. And 6k plus 5 is kh squared. I'll just double check. So I'm just plugging the first equation into the second two, getting rid of all the a's. And that's fine. So now the question is, all right, we want the values of k, correct? Well, we're going to have to solve for both k and a. Yeah. Determine all values of k with k not equal to 0. Could you even get one with k equal to 0? No, because they're saying k not equal to 0 because otherwise it's not a parabola and therefore it has no vertex. Okay, fair enough. Okay, so what can we do here? Well, it's a written question, so you might... it's sort of nice etiquette and makes your stuff look a lot nicer and neater if you put 1 and 2 beside your equations so you can refer to them. But, rearranging 1, let's say, we see that h is 5k plus 3 over negative 2k. And let's say plug this into 2. It looks like we'll get a quadratic here. So 6k, oh, maybe we'll get a cubic actually. 6k plus 5 has got to be equal to k times 5k plus 3 over minus 2k, all squared. So that'll be k times 25k squared plus 30k plus 9. 3 times 5 is 15, times 2 is 30, okay. And that'll be 4k squared down here. Now one of these k's and one of these k's will cancel. And so we'll say multiply by 4k on both sides. We'll get 24k squared plus 20k has got to be the same as 25k squared plus 30k plus 9. And now we've got the makings of a nice little quadratic equation. Bringing everything over onto the right side, 25 minus 24 is just going to be 1k squared. 30 minus 20 is 10k. We'll have plus 9. And this can be factored as k plus 1, k plus 9. Because 1 and 9 add up to 10. So that should tell me k is minus 1 and k is minus 9 will do. Those are our only answers. Nice little quadratic, that's fine. If you wanted to, you could do a little double check. What is the parabola associated to k equals negative 1? Well, it looks like negative x squared plus 5k plus 3 is going to be negative 2. And then plus 6k plus 5, that's going to be minus 1. And that looks like negative x minus 1 squared, which does indeed have its vertex on the x-axis. And the other one, if you're interested, is minus 9x squared. And then it should be, so 45 plus 3, or minus 3 is 42. And 6 times 9 is 54. Minus 5 is 49. Okay, and that's going to end up being minus 9 times... Oh gosh, this is going to be so much fun. Minus 7/3. Yeah. No, plus 7/3. Oh, this one should be plus 1. My mistake. Yeah, I got my pluses and minuses all wrong there. But there we go. There's those two. And that, by our math, we've shown that those are going to be the only solutions. So there we go. And that wraps up question, what was it? Question number 5. And so up in the next video, we're going to be doing question number 6. Until then, take care. I'll see you in the next video. Have a wonderful day.